Have you ever just stopped and looked at the device you're watching this on? I mean, really looked at it. The battery, the screen, that wireless signal magically pulling this to you? Every single part is the result of countless breakthroughs. It's so easy to take it all for granted, but behind pretty much every piece of our modern world, there's this hidden engine of progress. So let's pop the hood and see what makes it run. Okay, that seems like a totally random question, right? On one hand, you've got this massive feat of industrial engineering, and on the other, a supercomputer that fits in your pocket. But believe it or not, they actually share a common ancestor. There's a single, fundamental process that links nearly every technological leap we've ever made. And there it is. That common link is research and development, or what we all call R&D. It's this systematic, sometimes messy, but always crucial process of discovering new knowledge and then engineering it into the practical tools and systems that, well, literally shape our world. It's the bridge that takes us from a wild idea to tangible reality. But R&D is so much more than just a few scientists in a lab. You have to think of it as the engine that actually builds our world. It's what pushes the boundaries of what we think is possible, in everything from industry and technology to society itself. A good way to think about it is that R&D is kind of like the source code for progress. It can spark entirely new industries out of thin air, which seriously boosts a country's competitiveness on the world stage. It gives us the tools we need to tackle huge challenges. You know, things like climate change or public health crises. But at the end of the day, the goal is always the same: improving our quality of life and making the world safer, healthier, and more accessible for every single one of us. So we all agree it's important, but what is R&D really? Well, the name itself kind of gives us a clue. It's not one thing. It's actually two very distinct but deeply connected activities. Let's break it down. You can think of R&D as two sides of the same coin. First up, you have the R, research. This is the pure quest for knowledge. It's all about that systematic investigation to figure out why things work the way they do. Then you've got the D, development. This is where that abstract knowledge gets its hands dirty. It's forged into the real, tangible devices, materials, and processes we use every day. So one side asks why, and the other asks, okay, how can we use this? And these two halves, they don't work in a vacuum. They actually feed each other in this continuous cycle. It all starts with a need, right? A problem that needs solving. So research uncovers new insights, and that discovery fuels the development of prototypes. After tons of rigorous testing, a new technology is finally implemented. But here's the kicker. That new solution often reveals brand new questions or problems, which kicks off the next round of research. It's a loop that never, ever stops turning, and it's constantly pushing us forward. All right, theory is great and all, but let's see how this cycle has produced some absolutely incredible real-world innovations. We're going to zoom in on a few powerful Canadian examples that really show R&D in action. First up, a truly monumental achievement in the world of energy, the CANDO nuclear reactor. Now, this was not some overnight discovery. It was the result of a long, dedicated, and brilliant R&D program. The key innovation here was a major breakthrough in nuclear physics, figuring out how to use heavy water to control a nuclear reaction. This completely unique approach meant the reactor could run on natural, unenriched uranium, something most other designs just can't do. And that was a huge advantage. It totally eliminated the need for these really costly and complex enrichment facilities. The CANDO reactor didn't just become a cornerstone of Canada's energy strategy. It became a major technology export, proving that R&D can create both energy independence and economic strength. Okay, let's pivot from energy production to resource extraction. For decades, everyone knew that Alberta's oil sands held just vast resources of oil, but actually getting to it was a massive technical headache. The solution? It came directly from applied research. Engineers developed these totally groundbreaking technologies, like steam-assisted gravity drainage, or SAGD. What that means, basically, is they figured out how to inject steam deep underground to heat up that super thick oil, letting it flow so it could be pumped to the surface. This unlocked enormous economic potential. And that R&D cycle is still going strong today, now with a major focus on developing new tech to reduce the whole process's environmental footprint. For our last case study, let's look at how R&D isn't just about creating products, but also about generating critical knowledge. Specifically, we're going to look at how Canada keeps an eye on its vast and fragile Arctic. So using this cool combination of satellite imaging and remote field stations, geoscientific R&D creates this incredibly detailed picture of Canada's changing north.
And this isn't just abstract data for scientists to look at, it's vital intelligence. Knowing exactly how fast the permafrost is thawing, for instance, directly tells us how and where to build safer roads and buildings. It is a perfect example of how research guides policy to protect both people and the environment.
So we've seen the incredible power of R&D. I mean, it can build reactors, reshape landscapes, and unlock resources. But all that power to shape the future, it comes with an immense amount of responsibility. Innovation isn't just about what we can do, it's also about what we should do. And that brings us to the innovator's rulebook, ethics. Man, this really gets to the heart of it, doesn't it? Innovation absolutely must be guided by a strong moral compass. When you're dealing with technologies that can fundamentally change society, principles aren't just nice to have, they're essential. This whole ethical framework is basically built on one thing: trust. It starts with integrity, being honest about your results, even when they're not what you were hoping for. It demands accountability for public safety, putting that above everything else. And it requires being transparent about who's funding the work and, of course, respecting the intellectual property of others. If you breach this trust, you're not just risking your career. It can have serious legal and social consequences. This responsibility also means you have to embrace uncertainty. I mean, innovation, by its very definition, is stepping into the unknown. That means you have to be constantly assessing risks to make sure new tech is safe before it ever reaches the public. And in a world where technology evolves at lightning speed, your job is never really done. A commitment to lifelong learning isn't just a good idea, it's an essential duty. Now, as we look to the future, the world of R&D isn't getting any simpler. In fact, innovators today are facing a whole new set of really complex challenges that they're going to have to navigate, and navigate responsibly. First off, there's always the pressure of time and money. Breakthroughs are incredibly expensive, and they do not happen overnight. Then you've got these legal minefields like patent disputes that can just stifle innovation. We're also wading into some really deep ethical waters with things like AI and automation, raising huge questions about job displacement and who's really making the decisions. And kind of hovering over all of it is the ultimate balancing act. How do you create regulations that protect the public without grinding progress to a halt? From the Industrial Revolution all the way to the information age, R&D has been the engine of human progress. It has solved the great challenges of every era. So, as we wrap this up, I want to leave you with one final thought. What is the single biggest problem facing us today that you believe research and development absolutely must solve next?